Hello, lovers of Mathema. I'm welcoming you to another class on indices. For a while now, we've been treating indices as a topic, and we have solved some couple of examples and past questions in the last classes we've had. Today, we will be solving more questions on indices. And looking at the nature of the questions we have here, I have 6 questions here, and hopefully we are going to solve the 6 questions together in the course of this class. So let's first look at the nature of the questions here. You can see that we have no equal sign, we have no equal sign. So these are expressions, these are indices expression. And of course, in expression, during our foundation class, I've made a clear difference between expression and equation. In expression, uh, the basic things that you may be required to do is for you to simplify. So it means that they will give you maybe in a complex or in a bigger form, and you'll be expected to actually break it down to simplify it. So let's get to work. We have 6 questions to deal with. So the first one, number 1, okay, we have 27x raised to power 6 over y raised to power 3, all raised to the power of 2 over 3. So you hopefully know your laws of indices by heart by now, so we can begin to apply that. So if you look at the nature of this question, the first thing that should come to our mind is that law of indices that states that a raised power of m over n, and in this we know that what will n will become the root, and then we have our a, and that will be raised to the power of m. So let's give it this approach. Of course, you can give it a different approach, but applying the laws, let's stick with applying the laws. So we can say the 3 that we have here will become the cube root, and then I have 27 x raised to power 6. Okay, I have over y raised to power 3 and all raised to the power of 2 that remains here. So the interpretation now is that we are to find the cube root of 27, cube root of x raised to power 6, cube root of y raised to power 3. Okay, so when we say cube root, we mean that you should find that single number that when you multiply it 3 times, it will give you 27. When you multiply it 3 times, it will give you x raised to power 6. When you multiply it 3 times, it will give you y raised to power 3. So we'll do it one by one. What is that single number that when you multiply it 3 times, it will give you 27? So 3 is that number, because if we have 3 times 3 times 3, that will give us 27. So 3 is that single number that when you multiply it 3 times, it will give you 27. So our cube root of 27 will be 3. Cube root of x raised to power of 6, that would be x raised to power 2 times x raised to power 2 times x raised to power 2. So, you know, according to the laws of indices, that would be 2 plus 2 plus 2. So that's x raised to power 6. So x raised to power 2 is the cube root of x raised to power 6. So x raised to power 2 will be our cube root, and then y raised to power 3, of course, y multiplied by itself 3 times is what will give us y raised to power 3. So the cube root of y raised to power 3 will be y. And then we have sorted this cube root, then we have now all square. Okay, so this all square with this bracket means that this power here, this exponent here, belongs to everything in the bracket. So let's separate it on them. So 3 raised to power 2, we have x raised to power 2 is here before, so it's now raised to power of these 2, okay, and then all over y raised to power 2, and that will give me 9 times 2 times 2 will give me 4 y raised to power 2. So my final answer will be 9x raised to power 4 over y raised to power 2. And this will be our final answer for number 1. So you can see the way we broke it down one by one. Okay, applying the laws of indices. Just stick with the laws of indices, and later on in the subsequent questions, we may begin to explore what other methods, what other ways, how else can you express this and all that. So they are all actually obeying the laws of indices, whichever methods that you may use. So here also, number 2, we have number 2. Let's give it the same approach. Okay, so I'm going to use this as the square root. The 2 will become the square root. So that's the square root of x squared over 49 y raised to power 4 all into brackets raised to power minus 1. Don't forget, I've told you before that if it's not more than 2, okay, you may not need to indicate it. Like here in number 1, it's cube root, I put 3 there. But if it's square root, you don't need to put 2. Okay, so it is already known that it is 2 that is there. You don't need to put your 2. If you put your 2, it only shows that you are a beginner in mathematics. It's not something that you can be penalized for. But this is square root, it means 2. It's only when the is now more than 2, maybe cube root, 4th degree of root, 5th degree of root, that's when you can indicate it. So I've already done my expression. The remaining minus 1 is already the power here. So as we interpreted this one, this is 2 here. It means that find a single number that when you multiply it by itself 2 times, you will get this, you will get this, you will get this. So what will you multiply 2 times to get x squared? That will be x, because x times x will give you x squared. Okay. What will you multiply 2 times to get 49? What's the square root of 49? That is 7. And what will you multiply 2 times to get y raised to power of 4? Of course, that will be y raised to power 2 times y raised to power 2, which is 2 plus 2. It will give me y raised to power 4. So I will say y raised to power 2 is the square root, and then I have what? Raised to the power of minus 1. Now, there is an approach that you should learn here actually. Of course, we can break this down, but we can write our answer also directly. The meaning of this raised to power minus 1 actually means 1 over. Don't forget, it means 1 over in the laws of indices. So let's write like that. So this minus 1 here, remember that law, it means 1 over x over 7 y raised to power 2. Okay, let me put it here so that you know that it is actually this 1 against x over 7 y raised to power 2. So this means inverse of x over 7 y raised to power 2. It means reciprocal of, it means that you should flip when you have 1 over something. So it means that if that thing is a fraction, you should flip it. If it's a whole number, you put it, you will leave it, your answer like that. But if you really want us to break it down, we can break it down to say 1 over means, this 1 all over means 1 divided by x over 7 y raised to power 2. Okay, so that will be 1 over 1 times, okay, when we are changing division to multiplication, you know that we flip the fraction by the right hand side. So that will be 7y squared. Of course, that's as a proof in mathematics, but I want to believe that you know that. So we now have what? 1 multiplied by this will give me 7y raised to power 2, and then I have what? Over x, and that will be my final answer. You see, so that's what I was actually trying to explain. Like here now, when you have 1 over, you can easily write your answer to say your answer is 7y squared over x. When you have 1 over something, it means reciprocal of that thing or the inverse of that particular thing. Okay, so in our subsequent examples, when we encounter something like this, I will just write the answer directly, and I hope you will understand by then. So that's our number 2. Let's move to number 3. Okay, this is our number 3. In number 3, we have this. Okay, so let's make it a bit faster than the number 1 and 2 that we did. Okay, hopefully we should make it faster. So straight up, I have my cube root 8a raised to power 6, and I have 27b raised to power 3. Okay, and then what I have left is what? Raised to power minus 1. What is the cube root of 8? A single number you will multiply 3 times to get 8. That is 2. What is the cube root of a raised to power 6? A single expression as such that you will multiply 3 times to get a raised to power 6. That will be a raised to power 2. A raised to power 2 times a raised to power 2 times a raised to power 2, something like this. A raised to power 2 times a raised to power 2 times a raised to power 2. This is what will give you a raised to power 2 plus 2 plus 2. That will give you a raised to power 6. So definitely a raised to power 2 is the cube root of a raised to power 6. So you put that a raised to power 2. What is the cube root of 27? Cube root of 27 will be 3. 3 times 3 times 3 will give you 27. What is the cube root of b raised to power 3? That will be b. And then I have what? Raised to the power of what? Minus 1. So you can see the same thing we have in that place that we did. Once you see that what is raised to the power of minus 1, it means 1 over, let me write that. So we just flip it directly. 1 over 2a squared over 3b. Okay. So what will be our answer? Our answer will be 3b over 2a squared. Okay, that's the reciprocal of that. So that is our number 3. So let's move to number 4. Okay, our number 4, we have 64x raised to power 3 over y raised to power 9, all to the power of minus 2 over 3. So straight up, I have my cube root of 64x raised to power 3 over y raised to the power of 9, and then I have minus 2 here. Okay, so what is the cube root of 64? Cube root of 64 is 4. 4 times 4 times 4 will give me 64. So 4 is the single number that when you multiply 3 times, it will give you 64. So the cube root of 64 is 4. What is the cube root of x raised to power 3? That is x. What is the cube root of y raised to power 9? That is y raised to power 3. Of course, you know that y raised to power 3 times y raised to power 3 times y raised to power 3. Okay, that will be 3 plus 3 plus 3. That will be 9. So this one is the cube root of y raised to power 9. So I hope you understand that now. And then I have all raised to the power of minus 2. Now I can separate this easily. Okay, you remember the law of indices. The minus here will become 1 over according to that law. And then I'm going to have 4x over y raised to power 3. So the number here is 2. So I'm going to put my 2. Okay. So now I can continue by saying 1 over. Let me first separate this square here. This square belongs to all of them. So that will be 4 square x square over y that is carrying 3 here before is also now carrying what? The square, because this square here belongs to all of them. So I can now say that what? That will give me 1 all over 4 square is 16. Then I have what? X square. 3 times 2, 6. That will be y raised to power 6. And then if I flip this because of 1 over, if I flip it, it's going to give me y raised to power 6 over 16x square. Okay, and that will be my final answer for number 4. Right, I hope you are finding it easy. So let's move to number 5. We are doing fine, and you are doing great if you are following me. Make sure you follow this video to the end, and make sure you share this video out immediately after you have gone through the lecture. Comment down in the comment section, let me know, and just comment I understand. Thank you. Thank you, we do. Okay, well done, we do. Like the video and share it out. subscribe to the channel, and make sure that you hit the notification button. So number 5, I have 2a raised to the power, okay, of 5, 2a raised to the power of 5, b all to the power of 3, and d is at the denominator. So let's separate these 3 on top of all of them first. That will be 2 raised to the power 3, a raised to the power of 5 raised to the power of 3, okay, and then I have b raised to the power of 3 over 6 raised to the power of 2, a raised to the power of 2, then raised to the power of 2, b raised to the power of 2, then raised to the power of what? 2. So that's the first approach. So here I have 2 raised to the power of 3, that can give me 8. 6 raised to the power of 2, that will give me 36. That's because I'm not seeing any number to the index form of 2 or to the index form of 6. So let me still rule it. Then I have times a, 5 times 3 will give me 15. B raised to the power of 3 times this one also, a raised to the power of 4, 2 times 2, and then I have times b raised to the power of 4. Now let me separate all of them according to their lifetime terms. So 8 over 36, that's number, we go with number. A raised to the power of 15 over a raised to the power of 4, that will go together. And then I have times b raised to the power of 3 over b raised to the power of 4. So I can say that here perhaps I can use 4. 4, if I want to bring this down, I can say 4 in 8 will give me 2. 4 in 36 will give me 9. Okay, that will now be times a raised to the power of 15 divided by a raised to the power of 4. Okay, that's what that will give me, times b raised to the power of 3. This line here means divided by b raised to the power of 4. Okay, now I have 2 over 9 times, according to law of indices, a raised to the power of 15 minus 4 times b raised to the power of 3 minus 4. So I have 2 over 9 times a raised to the power of 11 times b raised to the power of what? Minus 1. Okay, so I can say this will give me 2 times a raised to power 11. Okay, and I have this over 9, don't forget. Okay, times 1 over b. Okay, so let me also put this over 1 so that it will also look like a fraction. Okay, so we can easily look at that and say, let's multiply all the numerator and multiply all the denominator. So 2 times a raised to power 11 times 1 will give me 2a raised to power of 11 over 9 times 1 times b will give me 9b, and that will be my final answer. All right, I'm excited. We are almost done. So this is our number 6. Okay, right. This number 6, I would have loved to give you as a question you can practice with. Okay, or maybe I should just do that. So let me leave you with this number 6. Try to give solution to this number 6, and then you can comment your answer in the comment section below. Let me receive your answer in the comment section, and you can also send your workings, okay, to our Telegram channel or our WhatsApp channel. So let me check out what you have done. Thank you very much for staying through with the class today, and try to share this video out. Do the needful, subscribe, hit the notification button, like, comment, and share. All right, till next class. See you. Bye.